Hello everyone, welcome back to Code with me, Manasa. Today we are in part 7 of our data science series and we are covering one of the most important steps in any data science project, that is exploratory data analysis, commonly known as EDA. So EDA is the phase where we get to know our data deeply, understand its patterns, spot problems and discover hidden insights. Before we build any machine learning model, EDA helps us avoid mistakes and prepare the data properly. So let's begin. So first we have to know what is EDA. So EDA stands for Exploratory Data Analysis. So it is the process of understanding the structure of the data. The main point of understanding the data is should understand the structure of data and what is the type of the data. Next, detecting patterns, identifying issues, finding relationships between variables. So think of EDA as the initial health checkup of your data. You don't jump into modeling immediately. You first explore the data thoroughly. So let's see why EDA matters. So why it is most important in data science projects. So EDA is most important because it prevents model failure. If we skip EDA, we might miss. So what we might miss is missing values, outliers, incorrect data types, skewed distributions, wrong assumptions. So EDA helps us find insights even before machine learning. So it ensures the data is ready, clean and meaningful. So let's see the types of EDA we have. So there are different types of EDA. One is univariate analysis, analyzing a single variable. So next is bivariate analysis, comparing two variables, and next is multivariate analysis, studying multiple variables at once. So we'll explore each type of EDA with examples. So let's see univariate analysis. So univariate analysis means studying one variable at a time. So for example, age is a one variable, and next salary, product price, temperature. So we use univariate analysis to understand the distribution of a variable. So common plots include histogram. You can see on screen there is an histogram illustration how it is between frequency and value ranges. So each variable is distributed in EDA analysis, that is univariate analysis. So and next we can use KDE plot or box plot or bar chart for categorical data also. And we have a code snippet that uses EDA, and also this code snippet will give the whether data is normal, skewed or has outliers. So SNS dot histplot in the sense it is histogram and define age, so it gives the histogram plot of age. So next, distribution plots. So we have distribution plots. How is data spread? It is systematically skewed. Are there peaks and gaps? Are outliers present? So common distribution plots, you have seen histogram, KDE and frequency plot also. Studying distribution is essential before building models. So distributing the data into their type, into their category or into their variables, it is more important before building the models. So what are the summary statistics? So before plotting everything, we have to summarize some things. So it's helpful to check summary statistics also. They include mean, median, standard deviation, minimum and maximum, skewness and kurtosis. So there is a graph here uh, where there are some statistics with values. So mean, meridian deviation, skewness and kurtosis. So these are the sample values where n is equals to 100. So these statistics give a quick overview of central tendency, spread and shape of the distribution also. So let's see bivariate analysis. So what is bivariate analysis? Bivariate analysis compares two variables together. So for example, what are the questions we can ask is, does age affect salary, does price affect sales? So it shows the link between two variables like age and salary, and price and sales, gender and spending. So common tools for bivariate analysis are scatter plots, correlation plots, box plots, and line charts also. This helps us identify relationships between two variables. So how scatter plots and correlation have bivariate analysis. So when both variables are numeric, we have scatter plots. For example, scatter plots helps us detect positive correlation, negative correlation, and no correlation. And we have clusters also and outliers. So we can use uh, calculate correlation numerically using dot core of. So this reveals how strongly two variables are related. So this is bivariate analysis. So we can use box plots also. Compare a numeric value versus a categorical value. So it compares a numerical value with categorical value, like let us take gender versus salary. Gender is a categorical variable and salary is a numeric variable. So here is the box plot illustration with men and women. So men and women are gender and they have a salary distribution here. So you can see on the screen. And uh, a box plot shows how median, quartile, spread of data, outliers. So box plots are extremely useful for spotting inequality and unusual behavior in categories. So let's see multivariate analysis. So what is multivariate analysis? Multivariate analysis, it shows multiple relations, like multiple relations in the sense, like we have seen bivariate analysis. We have taken the two categories and we have compared them. We have checked the correlation between them. So here multivariate comes with three or more variables together. So multivariate analysis studies three or more variables together. So this is very useful in data science because most real world problems involve multivariate features. For example, age, income and spending, height, weight and BMI, marketing spend across channels. So multivariate analysis uncovers deeper patterns that univariate or bivariate analysis cannot detect, multivariate can detect. So let's see an heat map. So what is an heat map? One of the most popular tools in multivariate EDA is the heat map. So a heat map visualizes the correlation matrix. So for example, here is a Python snippet, sns.heatmap of define correlation. So it gives a correlation between, in the define correlation, we can give what variables we are going to see the correlation between, and it gives us the heat map. You can um, use this code snippet in your Jupyter and you can run and you can see the heat map here. And this allows us to quickly see strong relationships, weak relationships, negative correlations and redundant features also. Heat maps are essential for feature selection. So we have a choice of selecting the features in the data. Heat map helps us to select features. So next, let us see pair plot. Pair plot is another powerful visualization tool. So it creates scatter plots for every pair of variables and histograms for each variable, a full overview of relationships in the dataset. So here is a Python snippet, sns dot pair plot define. So here it gives us the pair plot. With just one line of code we can get a complete multivariate visualization. So and next, pattern detection, how patterns are detected in data science. So EDA is also used to detect patterns such as trends, cycles, seasonality, repeating behavior. For example, sales may increase every December, temperature rises every summer. So pattern detection helps businesses make predictions and decisions for future. Let us see what are outliers and anomalies. So outliers are extreme points that don't follow the normal pattern. Like we have discussed about outliers, we have discussed in the before videos also. Let us take an age here. We have a data set which contains age group between 20 to 50, and there are two or three age groups in 140. So that 140 age group is an outlier for 20 to 50 dataset. So outliers are extremely points, so they are differ from normal pattern. Anomalies can indicate fraud, errors, unexpected behavior, rare events. So detecting anomalies early in crucial stage in finance, cybersecurity, and quality control. So let's see what is the importance of a feature. So machine learning algorithms can also tell us which features are most important. Feature importance helps us remove unnecessary features. So identify key drivers of prediction, improve model accuracy, simplify the dataset. This step is often done after initial exploratory data analysis. So we have a feature importance chart here. So we have the rankings here, like feature A, feature B up to feature F, and we have the ranking here. So what is the importance score of that feature? So there is a rank for each feature, so that which feature is very useful and which feature is less useful for making the machine learning model. And next, EDA tools. Let's see some EDA tools. For EDA, we commonly use pandas for data manipulation, as we know, and we use matplot library for basic charts and visualization purpose, and seaborn for statistical plots, and power bi, or else we can use tableau also in the place of power bi for dashboards, for creating dashboards. So these tools make EDA fast, visual, and effective. So let's see EDA checklist. So which performing EDA on any dataset, follow this checklist. If you want to perform any EDA, exploratory data analysis, on any dataset, follow these checklists. First, handle missing values, and next check for outliers and study distributions. What is the data, and what data is there on which category, and distribute them into a need of data, and analyze correlations between variables and features, and check data types, what are the types of data we have, and identify scaling needs, look for patterns also, and understand relationships. So this checklist ensures you never miss anything important in the data, which is very important in building machine learning model in data science. So let's summarize this video. So EDA gives us deep understanding of data. It helps find issues early. So it guides pre-processing and feature engineering. It improves model performance also. It ensures the data tells a clear and accurate story. So EDA is the most important part of any data science workflow. So thank you for watching part 7, Exploratory Data Analysis and Data Science series. If you have enjoyed this video, don't forget to like, subscribe, comment, and share with your friends. Your support helps me continue this data science series. This is Code with me, Manasa, and I will see you in the part 8. Thank you so much for watching.